and welcome to our latest episode of Hungry Scientists. I'm Sophie, and this is Karl.
Hello everyone.
So, Karl, what will we learn today?
Today I will talk about pancakology.
Pancakology? That's the science of making pancakes, right?
Exactly. We will start with the simplest crepe, with only 2 ingredients, then we will make classic French crepes, then pancakes, and finish with the fluffiest Japanese pancakes.
That sounds delicious.
So for the simplest crepe, we will only use water and buckwheat flour. Do you know what buckwheat is, Sophie?
It's probably related to wheat. It must be some kind of cereal, right?
Wrong. The name is misleading. It's actually a flowering plant originating from Asia, not a cereal. Let's look at our batter under the microscope. When mixed with liquid, the starch granules absorb water and swell, forming a gel-like network that gives the pancakes their texture. You know, people from Brittany have been doing these crepes since the 13th century.
We can see tiny bubbles forming. What are these?
As you can see, it's very flat and dense. There is very little air trapped in the crepe unless you add a leavening agent such as baking powder. What happens is that the batter solidifies quickly, and then the water evaporates, but it's too late and the dough just breaks to let the vapor escape. And finally the sugars caramelize and give a little brown color to the surface.
They look very filling. If you add a bit of cheese and bacon, I'd bet it could easily be a full meal.
Absolutely, you can eat them as a meal or make a dessert. They are very versatile. For our next crepe, I will invoke the power of eggs. We will also use wheat flour and milk.
That's just 3 ingredients, still pretty simple.
The proteins in eggs coagulate when exposed to heat, helping to set the structure and providing some moisture. Yolks contain emulsifiers, such as lecithin, that helps create a stable emulsion between water and fats. This contributes to a smoother and more uniform texture, enhancing the overall mouthfeel.
Could we replace the milk with something else?
Oh yes. Milk can be replaced with buttermilk, which is more acidic, providing additional leavening and contributing to a tangy flavor. You can also replace milk with beer. It won't provide proteins or fat, but it adds interesting aromas, and the CO2 bubbles will make the pancakes fluffier.
So, now we arrive to the traditional pancakes we all love.
Yes, and for that we add just 1/4 ingredient, a leavening agent such as yeast or baking powder. When using yeast to make pancakes, you will need to allow the batter to rise for some time before cooking. This will give the yeast time to ferment the sugars and produce carbon dioxide. The resulting pancakes will have a slightly tangy flavor and a denser texture than those made with baking powder. Baking powder contains a combination of 1 or more weak acids, usually cream of tartar or monocalcium phosphate, and a base, usually sodium bicarbonate, better known as baking soda. The acid and base will react together and produce CO2 bubbles, making the pancake light and well aerated. The base and acid are prevented from reacting prematurely by the inclusion of a buffer such as cornstarch. Most baking powder nowadays are double-acting, meaning that they produce gas a first time when mixed with water, then another time when the temperature reaches between 60 and 80 degrees Celsius, or 140 to 176 Fahrenheit, which coincides with the zone where eggs coagulate.
And finally, the fluffiest of them all. Japanese pancakes.
Yes, Japanese cuisine has perfected the art of making pancakes as fluffy as possible. No new ingredients here, but we separate the eggs. Egg whites are rich in proteins, primarily ovalbumin, which can form a foam that traps air. When beaten or whisked, these proteins unfold and form a stable foam that contributes to the leavening of the pancake batter. We put the batter in the pan, wait a few seconds so it solidifies, and now we put a second layer on top. Look at all the little bubbles we have already trapped in the egg whites. And now, the temperature reaches 70 Celsius, and we have the second rise from the double-acting baking powder. A little more time to let the sugars lose water and caramelize. Here, that's perfect.
Oh my god, they are so fluffy!
Of course, in all those recipes you can add more ingredients. For example, fats like butter and oil make the texture more tender by coating flour proteins and inhibiting gluten formation, and adds richness to the flavor by enhancing the Maillard reaction, a chemical reaction between amino acids and sugars, responsible for the browning.
Fat also helps prevent the pancakes from sticking to the cooking surface, and helps them retain moisture if you don't eat them all immediately.
That seems highly improbable.
You don't think fat helps pancakes to keep moisture?
Oh yes, I meant the part about not eating them immediately. You can also add sugar, but be careful, sugar is very sensitive to heat. It starts caramelizing at 160 Celsius, 320 Fahrenheit, and will turn bitter and burn if you let the temperature rise above 180 Celsius, or 350 Fahrenheit.
I like adding a tiny pinch of salt, too.
Salt is great to enhance the overall flavor of pancakes. By regulating flour enzymes and slowing yeast activity, it also limits gluten formation and contributes to a more tender and less chewy texture.
Well, I think it's all for today. Thank you, Karl, for this Pancakology 101 course.
It's always a pleasure.
See you next time for another episode of Hungry Scientists.